No discussion of functions in C would be complete without a discussion on function prototypes. Function prototypes are a feature of the C language that, interestingly, cannot add any extra functionality to your programs. Their sole purpose in life is to try and make your development cycle shorter. In other words, they're trying to cut down on the number of errors that you create as a programmer. Your program will still work the same, it will still do everything that it did before, but hopefully it will have less bugs in it. So, what is a function prototype? Let's have a look. Well, a prototype is a synopsis of the correct use of a function. What does that mean? What is the correct use of a function? Well, if you provided me with a function and asked me to call it, then for me to call it correctly, I would have to provide the correct number of parameters. The parameters would have to be in the correct order, and if that function returned a value to me, I would have to store that value in an appropriately typed variable. Then I would be deemed to be using that function correctly. So a prototype is a synopsis of this. It tells me what parameters there are to a function and what the return type of the function is, as well, of course, as the function's name. Okay, so what does a prototype actually look like, and where do you put them? Well, a prototype really just looks like the first line of a function. If you took the very top line of a function, in other words, the line that contains the function's name and all the parameters and the return type, and put a semicolon on the end of all of that, you would get the prototype. You're not actually supposed to put the semicolon right there in the actual function. What you're supposed to do is copy and paste that top line. You take a complete duplicate of the top line of a function, paste it somewhere else, and then put the semicolon on the end of the duplicate. That gives you the prototype. So, where should these prototypes be put? Where should you copy and paste these lines to? Well, the answer is you should paste them anywhere in your C program at all, as long as they are before the very first instance where that function is called from. In other words, if you had a function called, say, add, and you call that function 6 times throughout the course of your program, then the prototype for add should go above each of those 6 calls. In fact, the best place to put it is right at the top of the file, up near the global variables, before you actually get to any functions at all. And in fact, the very, very best place to put these prototypes is into header files, and have those header files included in all of the .c files that use the particular function that you've got in question. It is by using these prototypes that gives your compiler extra information that it can use to check to see whether you're calling your functions correctly. Every time you call your function, the compiler can compare your call against the prototype and determine whether you're doing it correctly or not. Let's have a look at an example of a prototype. Well, let's take the example from a previous module, the average3 function. Now, you can see before you the prototype for that function. It's really just the line that contains the top line of the function itself with a semicolon on the end. That is a prototype. There's actually another form for a prototype as well. It's very similar. Let's have a look at that. It's exactly the same, but without the variable names in it. It's possible to omit the variable names here because the compiler itself is concerned with the correct calling of the function. And the correct calling of the function simply means that you've got the right number of parameters and they are of the right type, and that the return value is of the right type. That's the only information that the compiler uses to check each of your calls to that function. And so, correspondingly, that's the only information that you absolutely need to put into the prototype. Let's go now and have a look at an example of where omitting a prototype can get you into trouble. Here's our average program again, this time saved as average4.c. Now I've added a line to this program, kind of an odd line, doesn't really belong where it is, but I've added it anyway just to demonstrate how this can go wrong for us. I've added this printf line here. I've decided that I want at some point to determine the average of 4 and 3, and so I call our function called average3 from here. Now where is average3? Well, average3 is down here further a little bit. So as you can see, I'm deliberately calling average 3 incorrectly. Average 3 requires 3 parameters and I'm only providing 2. So let's see what happens when I try and compile that. Now I get 0 errors, but I actually get a considerable number of warnings. A warning means that the program will actually run now. There were no errors, so the program has been completely compiled, but there are warnings, which means that if I try and run it, something might go wrong. So let's try and run it and see if something actually does go wrong. I'll try and run it now. Please enter the first number, say 1. Oh, there we go. The average of 4 and 3 is 0. Now that's clearly incorrect. Alright, well I'll just complete the program. Let's go back and have a look. So now if I didn't see those warnings, if I just ignored them, then I would be now trying to figure out why my average program wasn't working, saying that the average of 4 and 3 is actually 0. Fortunately, I have some warnings to help me. Here I have my first warning, type mismatch with previous implicit declaration. I wonder what that means. Let's see if we can find any further. Here's another one. This might give us a bit of a clue. Warning, average 3 was previously implicitly declared to return an integer. Aha. Now this is telling me exactly what's going on. Now that line, if I double click on that warning, it takes me down to this definition here of average 3. And the warning tells me that this was previously implicitly declared to return an integer. Now it's actually returning a float. But here's what's going on. As the compiler walks through the code line by line, it might occasionally encounter a function such as this one that it knows nothing about. It's encountered a function called average 3, but it has not yet read the definition of average 3. It doesn't know anything about average 3. So what it does is it assumes that average 3 returns an integer. That's the assumption that it makes. And all compilers, all C compilers, make exactly that same assumption. Then it continues walking on down through the code until it gets to this line and says, this is really a float, and I've got it previously assuming that it's going to be an integer. So I've got something going wrong here. Now when I come along and read these warnings, I can learn from them that I've made a mistake somewhere, that I'm actually calling the average function before I've defined it. So I think to myself, oh, well, okay, what can I do about that? Well, I could take the average 3 function and simply move the whole function up to the top of the program. But it may not be appropriate to do so. It may be appropriate that the average 3 function live exactly where it is. And it may not solve the problem either, because there are circumstances, believe it or not, where it is not possible to move the function above the first call to that function. I'll leave you to figure out what circumstances that might be the case in. So if I can't move the definition of the function above the call to the function, then what can I do? Well, I can put in a prototype. So that's what I'll do now. I'll actually take this entire line of code here and I'll copy it. I've now just done a copy, and I will put it right up the top here. I'll just put that one line, but I'll put a semicolon on the end to make it a prototype. So now what happens is, as the compiler reads through this program, it walks through it line by line and it encounters this first. This is the very first thing it encounters, and it says, oh, okay, so there exists a function somewhere called average 3 that has the following parameters and the following return type. Okay, that's very interesting. I'll store that information away for future reference. And then it comes down here, and now it finds my call to the average 3 function. It says, aha, well I do know something about the average 3 function, so I'll be able to check whether this guy is calling them correctly. So now let's try and compile and see if that makes any difference. Now one error. Too few arguments to function average 3. Aha, now that's a really good thing. Notice that before we didn't actually get that error. Before, we had called average 3 incorrectly with the incorrect number of parameters, and we got no error message about it. Now that I have a function prototype in there, I am actually getting an error. So I can go about fixing it without trying to run the program, find that the program doesn't work properly, and seeing if I can figure out why it doesn't work properly. the compiler has directed me to the exact source of the error without me having to do any thinking whatsoever. This is what prototypes are for. So now I can fix it up. I can say 4, 3, and 5, add a third parameter, and I can do this, 4, 3, and 5, and now I can run the program, and let's see, please enter the first number. The average of 4, 3, and 5 is 4, so that is now working. Okay, excellent. So now that we know all this, there's sort of a golden rule that applies to functions. Whenever you create a function of any sort, create a prototype for it as well. In other words, copy and paste that one line of code, take it up to the top of the file, or better yet, take it to a header file, a .h file, and paste it there and put a semicolon on the end. It is a bit of extra work for you to do, and there are a couple of circumstances where you can get around that rule and it's not absolutely necessary. Like if you have a very, very simple .c file, if you have a very, very simple C program and they're all the functions are in the same .c file, then you probably don't really need to worry about it. But when you're doing any large-scale system development using C, using prototypes is an absolute must. It will dramatically cut down on the number of bugs that you introduce into your program. Okay, so that's it on